the president, Alice has to be vice president. There are no other restrictions. What was the problem with this one? Just understanding the question, understanding the wording, or just the math? I'm just curious. The wording or the math? Do you understand what they're telling you? You just can't put the numbers to it? Both, okay. So what this means is there's 3 positions, and this would be a permutation, and this is one I'm definitely going to do with the slashes, so I can use labels, because if I just use formulas, it's very hard to use formulas on anything with restrictions, I think, and it doesn't give me that opportunity to put labels down. So if Alice is president, Barb must be vice president. If Barb is president, Alice must be vice president. So those are 2 different situations. In math, we call them cases. So I would have case 1. Case 1 just refers to the first thing that could happen. I have 3 positions, correct? I have the position of president, vice president, and treasurer. All right, so now what's here? If Alice is president, if she gets selected president, that's Alice, then Barb has to be vice president. That's what Alice said, right? There's 1 Alice and 1 Barb. How many people are available for treasurer then? 18, okay? So that would be 18 different ways. 18 different ways if Alice is president. Okay, that's one way this scenario can happen. There's a case 2 though, isn't there? What's another way that this situation can, I've got president, VP, and treasurer. Alice goes here, or sorry, Barb goes here, and Alice goes here, right? 1 Barb, 1 Alice. 18 people. So 18 ways if Barb is president. So this is what happens when we get stuck. When you try to do a permutation where there are more than one way to do something, it's called, we separate into cases. When you run into like a conflict. Is there any, whoops, that's case 2. Is there any other scenario that could happen in this class? Alice could be president or Barb could be president. What else could happen? Neither of them be president. Okay? So that would be case 3. And that means this is still president, vice president, treasurer. This is not Barb or Alice. Agreed? Now the way it works, if this is not Barb or Alice, this is not Barb or Alice either, right? Because they work as a team. So this is not Barb or Alice either. Okay, so treasurer, the treasury position though could be anyone, right? Barb and Alice could be treasurer. All right, so how many people are available to fill the president's job if Barb and Alice can't do it? 18 people, right? And then there'll be 1 less person because 1 person's doing president job. So 1 person president, Barb and Alice, that's 3, so there'll be 17 people left here, right? Okay, how many people are now, I had a class of 20, 1 of them's president, 1 of them's vice president, 18 are left over. Okay, so how many ways would this represent? Let's see. 5,508 ways if Barb, Alice, not president or vice president. Okay, so in this type of math, the word and means multiply. So I'm just going to do that down here. In this type of math, and means multiply. because the events are happening at the same time. That's the fundamental counting principle, right? M times N. Okay, so what I'm saying here is this situation happens at the same time, right? This is one situation. If Alice is president, that means and Barb is VP, right? And that leaves 18 for treasurer, correct? That's all happening at the same time. And means multiply, or the or situation means addition. So when I'm adding cases together, I'm adding the possible scenarios that could happen. So if you think about it, either this scenario happens, agreed, case 1 happens, or case 2 happens, or case 3. They can't all happen together. These events happen together, these events happen together, these events happen together, but separately it's either Barb is president, or Alice is president, or one of the other 18 is president. So multiply across, add down, you could think of it that way. So I've got 18 plus 18 plus 5508, and I get 5,544 ways to elect a president, vice president, treasurer under those conditions. Now you'll know, we're going to learn more about cases today, and you'll start to see what a case question looks like. You'll kind of know when you get a case question because you get stuck, right? You can't, when you go to do your choices in the slots, it seems like they're changing all the time. And when you get into that situation, you think, well, I don't know how many people are left because she could go here or she could go here. When you get that situation, you know it's cases. Any other questions on the homework? I told you only do up to 7, right? Did I tell you to do number 7? 8 and 9 will involve cases as well. 7, 8, and 9, and 10 will all be easier to do after today's lesson. Okay? Yeah.
I didn't do question
2? That was a bit tricky, I think. You know why? Because of that word repetition. Okay, let's take a look at case 2. Yeah, or case 2, number 2. Okay, number 2 says, you are programming codes for universal remote. Okay, each code must contain 5 digits. Lots of things get coded with, you know what else gets coded with codes? You guys probably don't know this because if you don't live in a house, probably lots of you are in apartments now, but garage door openers, they're coded with a PIN code. So that when you press it up, you're not pressing your neighbor's up, right? And they're not pressing yours up. That's another thing that has a code. You're programming for a universal remote. Each code must have 5 digits. The digit 0 cannot be used. Pay attention to that because 0 causes problems. We're going to see today that 0 can cause some big problems. Anytime you're dealing with a digital PIN or digital code, 0 can cause some problems. Okay, so I'm just going to highlight that. 0 cannot be used, and you can repeat digits. Okay, so I need a 5-digit passcode. 1, 2, 3, 4, 5. And my digits of 0 can't be used. I've got 1 through 9, right? Okay, so usually 1 through 9 represents 9 digits. Just keep that in mind. But as soon as I read part A, I see, oh, they're not letting me use 0, so I only have, or sorry, normally 0 would be 10, right? Digits 1 through 9 is 9 digits, but they're not letting me use 7. So without 7, without the number 7, my choices are reduced to 8. because 7 and 0 are both out. So that means I have a choice of 8 digits for the first position, right? They're telling me I can reuse digits. So it would be 8, 8, 8, 8, 8, which is 8 to the power 5, 3, 2, 7, 6, 8. Okay, now we go to B. 3 is in the third position, 5 is in the fifth. 1, 2, 3, 4, 5. Okay, so 3 has to go here, 5 has to go here. I only have 1 5 and 1 3. Okay, how many other digits do I have? 9. 9, 9, 9. So 9 exponent 3, that would be 729. Okay, part C. Begin with an even digit. Okay, Adam, how many even digits are there in my group of 1 through 9? 2, 4, 6, 8. So I have a choice of 4 here. After that, no other restrictions. So 9 exponent 4 times 4. 2, 6, 2, 4, 4. And then D, begin and end with an even digit. Okay, I have 4 here. This has to be even. This has to be an even number. This has to be an even number. They're letting me repeat, so that's another 4, right? 9, 9, 9. I think it was that repeat. Yeah. Normally, I think more questions than, we'll say not repeating. You can't repeat. But in the real world, you can repeat codes, right? Like you could have a code of 11111, right? They don't recommend it. Yeah. They don't recommend 1, 2, 3, 4, 5 either for a password. Okay, anything else here? Again, I only wanted you to do, if you did the first page and just got stuck on number 5, let's just be honest with me. Don't count number 5. How many people did okay on 1, 2, 3, 4, and 6? Did okay? Good. Okay, so that's just the basic understanding. That's great. That's all we want right now. These guys take a lot of practice. It also requires you to put on a whole new kind of thinking cap from normally what we've done in this class. Because you can see this is nothing to do with calculus, right? At all. Yeah. Okay, let's take a look. So yesterday we did quite a bit. We did some permutations with identical objects, right? Then we did some with grouping and a few restrictions, right? We looked at restrictions. And then we did some with grouping, and today we're going to do the last type of permutation, and then we're done permutations. Then we only have to talk about combinations and binomial theorem. Combinations are easier than permutations, by the way. They're a lot easier. They're a lot easier. You'll see, I don't know if I'll introduce them tomorrow, but because you don't get restrictions with combinations. They're just really general. There's no restrictions, there's no grouping, there's no identicals. Okay. Sometimes a permutation problem involves more than one restriction, and that's what happened with number 5. When you have more than one restriction, and the number of choices for one restriction affects the number of choices for a second restriction. In this type of question, we do cases. So we separate the question out into separate cases. And I call it when a conflict happens. So we'll see when we do this question. How many 4-letter arrangements beginning with either B or E and ending with a vowel can you make using only the letters? These are the only letters we're using. A, B, C, E, U, G. Okay, so we're not using the whole alphabet. We're just using those chosen letters. So I'm just gonna section off those letters for a sec, just so we can. These are the only letters we use, and my restriction is begins with B or E and ends with a vowel. Okay, so I'm going to do my slots first. It was a 4-letter arrangement, so 4 slots. So it begins with B or E and ends with a vowel. Okay, so how many vowels are available? A, E, U. Agreed? All right, so is there a conflict? Now, how you look for conflicts, if you see if there's a letter or a character or a person, if something appears twice. E. Yeah, E appears. These are both restrictions, right? Restriction, restriction. E appears in this restriction and this restriction. So when you see a common, something in common in restrictions, that's telling you you have to use cases. Now, I've got a restriction on the first digit, or the first place, and I've got a restriction on the last. I have to separate these guys out by restrictions, so basically what I do is I look at where the fewest number of restrictions are. So I can separate my cases into, it's either going to be words that begin with a B or an E, so that would be 2 cases, right? Words that begin with B, words that begins with E, so 2 cases. Or I can separate my cases out using the second restriction, which would be 3 cases. It doesn't make a difference, you'll end up with the same answer. So I always look at my restrictions and say, okay, well this has fewer cases, so I'm going to separate my cases out by the first letter. So we're going to say case 1. And I'll even add some notes in here because it's the first time we're doing it. So begins with B. Okay, so 1, 2, 3, 4. I know my B is going to go here, and I have 1 B. Okay, if I have a B in the first position, who's available? Which vowels are available to me? A, E, and U, right? Okay, so I have a choice of 3. Those are only choices, right? Okay, 2 of my letters are used up. 2 of my positions are filled with letters that are used. So 2 letters gone. 1, 2, 3, 4 left. And then 3. There's no mention of repetition, so when they don't mention anything, we assume that we can't repeat the letters. We're assuming that it's kind of like in kindergarten class when the teacher just put those letters physically on your desk and you just have those letters to play with. So 12 times 3, 36. Okay, 36 ways for case 1. 36 different codes if I start with B. Case 2 begins with E. Okay, 1, 2, 3, 4. This has to be E. I have 1 E. Okay, the E is filling the first position. So how many vowels do I have left for the last position? 2, right? Only A and U. The E is gone. That's what will happen with cases, right? And then I still have 4 letters and then 3 letters. So I've got 12 times 2 is 24, right? As we said, either the word begins with a B or it begins with E. Or means add. And this is factorial notation, or fundamental counting principle. So multiply across, and or means add. So there are 60 different passcodes that can be made with those restrictions. Okay. You ready to move on? Questions? All right, let's try the next one. How many 3-digit even numbers greater than 200? You can always tell a case question from the question itself as well because it gives you you can identify the 2 restrictions in the question. What are the 2 restrictions in the question? Greater than 200 and even. 3-digit is not a restriction, it's just that's how many slots you have, right? But you see even, greater than 200, so those, you know there's probably potential for problem. Let's see where the restriction is. 3 digits. Even number, let's do that. What does an even number, I defined what an even number was. You know what? I'm going to go back. Sorry, I'm going to go back to your vocabulary. We defined what an even number was, right? An even number divides by 2. Okay, I'm going to add something else in here, okay, just so you guys know. Even numbers end in an even number, right? So the last digit, if it's like a 5-digit number, the last digit has to be even. So it has to be 0, 2, 4, 6, or 8, correct? Odd numbers end in 1, 3, 5, 7, or 9, okay? So 5 choices, 5 choices. Just remember that. So, now you might have known that already, but sometimes you forget that when you're doing these case questions. Because if it says the number's even, all that means is the last digit has to be even. Not every digit, right? Just to drive the point home. This number here, look at this number. If I had like this 5, 9, 7, 1, 3, 2. That's an even number, right? Every other digit could be odd as long as the last number is even. Okay, so my last digit, even means my last digit has to be, and let's see, how many 3-digit even numbers greater than 200? Okay, and I'm only using, these are the only digits I have to use. So I'm using, this has to be the 2 or the 4, agreed? Yeah. Now, greater than 200, that means the number is going to be in the 200s, the 300s, the 400s, the 500s, right? Mm-hmm. So this digit is going to be a 2, a 3, a 4, or a 5. Right? Okay, who's causing conflict here? Who are the digits causing the conflict? 2 and 4, right? 2 and 4 are causing conflict. Maybe I'll add that for A too. Up here, it was E causes a conflict. Okay, now, do I want to break it up? There are shorter ways you can look at it. Sometimes when you look on the internet, people who've been doing this type of math for a long time, trying to shorten the cases up. I don't shorten my number of cases up. I always list the number of cases that I need because you'll always get a right answer there. So do you want to list 4 cases or 2 cases? Okay. I think so too. So case 1, we're going to say ends with 2. Okay, so 1, 2, 3. This has to be a 2, and I only have one of those. Now, if this ends with 2, my number can only start with 3, 4, or 5, right? So I have a choice of 3 numbers here. 2 of my numbers are used up. That leaves me with 3. Case 2 ends with 4. Okay, so if it ends with 4, how many choices do I have here? I've got 2, 3, and 5, right? Mm-hmm. So I've got 3 and 3. In this case, they were both the same numbers. That's okay. So I've got 18 different ways.
Okay.
Mm-hmm.
Just the last one. So you say the number should be an even number.
Mm-hmm.
One you use 2,
Mm-hmm.
right? So you left then where those
If the
3, 3,
two, if
7.
the two's going in the last position, okay? Sorry, the two's going in the last position here, so it can't be used in the front. So I only have 3, 4, and 5 to pick from for the front position. That's 3 choices.
Okay.
When two of my places are filled, 2 of my digits are used up, 2 of the digits are used up, that leaves 3 for the middle choice. Questions? You guys getting bored with this, or? All right, we'll do one more and then you can do the last few questions on that worksheet. How many ways can 4 girls and 3 boys be arranged in a row if the end of the row must be either boys or both girls? Okay, so I have 2 cases, correct? Okay, so I've got, if 1, 2, 3, 4, 5, 6, 7. So it's either girl, girl, right? And anyone can sit here. Would you say that? That would be case 1, correct? This is still a case problem. It's a little different though. What's the other scenario? What's the other possibility? BB, right? Anyone? Well, let's see what happens. So how many girls do I have to pick from? 4, and then 3. Agreed? And what's the middle going to be? 5, 4, 3, 2, 1, right? I'm just going to put 5 factorial. Because the middle doesn't matter, right? Or I could put my 5, 4, 3, 2, 1. Okay, how many boys do I have to pick from? 3, and then 2. 5 factorial. 1440. Okay, so they said, can you see this big or here? You either have both bookended by girls or bookended by boys, so it's either case 1 or case 2. Okay, so let's stop